please put some attention, please put some concentration here. So what do you mean by runtime stack mechanism in Java? Okay. So let me write a small Java program to understand this better. Okay. So I'm going to write a small Java program. So in this Java program, I am taking a name of the class as test. So this is very important. We must understand this class test. Name of the class is simply test. Okay. In this class, I am going to have a main method which is public static. Okay, let me write fully. Public static void main string array box. Right. So let me move this. Let me move this here. Let me move this here. Okay. Public static void main string array args. So this is the main method. We are going to have another method called public static. Let me take two methods. Want some interesting methods. I'm going to take eat biryani. Eat biryani is just a method. Doesn't mean that we have to eat biryani. Right? And again, I am going to take another method. Public static void eat more biryani. These are the two user defined methods. One is eat biryani. The second one is eat more biryani. So in this the second method, second user defined method, I am going to take a printout statement. System.out.println. So here I am going to write it was amazing. One statement is there in the eat more biryani. So in this, pay some attention. In the eat biryani, in this method, here I am simply going to call eat more biryani method. In the main method, I will be simply calling what? Eat biryani. So eat biryani. So main method has eat biryani method. Main method is calling the eat biryani method. Eat biryani method is calling eat more biryani method. And eat more biryani method as a simple online statement which is system.out.println, right? So look at this execution. Once we analyze this execution, you will understand this better. How this code could be executed in the Java. Right? Now you must understand one thing. So before actually, first of all, a developer has written a code. So this is the code written by the developer. Okay, let me take it in a simple box. So this code has been written by a developer. So the naming convention should be like this. How the code needs to be saved? We already know that they have to use the class name, right? So the name of the class is what? Test. So it has to be saved with the .java extension. .java extension, and the file name should be what? Test.java, right? So as soon as the code has been drafted by the developer, this code has to go through it will be sent to the compiler first of all, because compiler will check if the code has any errors. So the job of the compiler is to check if the code has any errors. So this is compiler. So compiler will take test.java file as the input, and it will generate .class file as an output. I can say test.class file. Test.class file. And after compilation, this code will be loaded into the JVM. This is the JVM. So here you have to focus a lot. This is what? This is JVM. Right? JVM actually does the execution, right? I've already said errors can happen here as well as errors can happen here, right? So compiler will usually check if the code is written with the correct syntax, the code has any spelling mistakes, if the code has any lexical errors. These things will be maintained by the compiler, right? But runtime JVM will handle what? Runtime errors. So compiler is going to handle compile time errors, JVM is going to handle runtime errors. This is one check, right? So if the compiler is compiling successfully, it doesn't mean that the code is not going to have any errors. I mean, it is not going to produce any errors in the future. It has more chances that the JVM can throw errors in the runtime. Okay? So before understanding that, now we are trying to understand runtime. This concept, runtime stack mechanism in Java. So JVM, as soon as the test.class file is loaded into the JVM, right, a main thread will be created and it is going to be the main thread. We know this already. Main thread will be created, right? At the same time, there will be a stack. There will be a stack frame. So this is the stack. So this. It is just like a bucket. There will be a stack frame, right? Let me stack frame. So what happens? The main thread will be created. At the same time, stack frame will also be created by the JVM, right? So this stack frame is going to follow what? LIFO principle. Last in, first out. You know this already. LIFO, right? So over here, the main thread will try to get access to the main method. So the main method is exactly here, right? So it will execute all the instructions that is available in the main method. But if you see here, now the first instruction inside the main method is what? Eat biryani. Before actually proceeding this stack, we have created a stack, right? This is a stack, right? This stack is going to save the main method in the form of a frame. Inside this, it is going to save main method. It will be loaded inside, because if you see the thread, this is the main thread, isn't it? Main thread is trying to get access to the main method first, right? So firstly, the main method will be stored in the stack frame, just like this, right? So after this is the first instruction. This is the first instruction. First instruction is again what? Inside the main method, we are calling another method. Another method is eat biryani method. So the control will go from here to here, right? And again, eat biryani is another method, isn't it? This eat biryani method, it will be saved in this stack, right? It is going to save eat biryani method. Right? So the control will go inside the eat biryani method. Right? And again it is going to call what? Again there is a call for eat more biryani. This time another method inside. There is a method inside another method. So again it is going to call another method, which is control will go from here to eat more biryani method. Right? Inside the eat more biryani method, since it is calling eat more biryani method, again there will be a record. We can call this as record, or we can also call this as stack. Activation records or stack, we can call it as. It's going to save the eat more biryani method. Eat more biryani this time, right? The eat more biryani, there is only one instruction, which is what? It was amazing, right? So this amazing is just an instruction. This is not a method. You must understand. Since it is just an instruction, so this is the output that will be generated in the console, right? In the console, in the output, no, it is going to generate. It is going to display what? It was amazing, right? It was amazing. Yes, it was amazing because biryani will always be amazing. From here, no, this is the last call, isn't it? This is the last call, right? Then is there any other call in the eat more biryani method? No, right? So the control will go from eat more biryani from here to the last call. From where it was actually called. It was actually called from here, right? From here to here, this will be executed, and the control will again go back to the same location, right? Hope you're able to understand. So this line got executed. After executing this line, there are no instructions here, right? So completely all the instructions in this eat more biryani got executed. All the instructions are executed here, right? Now what happens? The control will be again, it will go back to the where it was previously called. It will go back to the same location. So this was the area it was called previously. From here it was called, right? So the control will go back here. The control will be pointing, right? So all the instructions inside the eat more biryani got executed. So this eat more biryani will be deleted in the stack frame. I have already said it is like LIFO. LIFO means the last method that is going to get inside is the first method that is going to come out, right? So after this, what is the second method? Eat biryani method. So the control will remain in what? Eat biryani method. So all the instructions in the eat biryani method also got executed, right? So this eat biryani method will come out. In the sense, we can imagine this like this record will also be destroyed, right? And again the control will go from where? From eat biryani to the location where it was called, where the control came from. The control came from the main method, which is here. It will go back here, right? Then again there are no instructions. There are no instructions in the what? All the instructions in the main method got executed here, isn't it? Now this main method will be deleted from the stack frame, right? This has something to do with the exception handling concept. This is very important to understand the exception handling in Java, right? I hope you are able to understand this. Let me code this so that you will get much idea. So every time when you are coding this, this is what we call it as runtime stack mechanism Java. This is a runtime stack mechanism, and this is called a stack. Stack is an area in the JVM. This is a memory area in the JVM. It is going to store all the methods, all the method calls. Instead of saying methods, you can say that all the method calls by using the LIFO principle, last in first out concept, right? So the moment the method calls are loaded, the last method call, as soon as the last method call was executed, that method will be destroyed from the stack, and it will follow since it is following the LIFO principle, the last method that is going in will be the first method that is coming out. It is going to follow the stack principle, right? So each and everything is called as activation record. Activation record, right? So let's try to understand this in the programming language. It's very simple. Class test. Here I have the class test, right? In the class test, I have taken a main method, public static void string array ops. So in the main method, let me take two separate methods. public static void eat biryani. So here eat more biryani. And in this eat more biryani, I'm going to keep a simple printout println statement. This was amazing. It was amazing. So here I'm going to call this. I'm going to use this method name here. I'm going to use this method name here. If I start executing this program, we can see only one line is getting executed. This is what we see. But what we don't see, we don't see this all. We don't see all these controls, isn't it? We cannot able to see, what is this main thread. These things are in our imagination part. These things we cannot see this. Are the JVM things. The only thing that we see is the program that we are writing and the output that we are getting. This is a program that we are writing, the output that we are getting. Internally, this many things are happening in the memory. Right? Let me run this. So for running, I need to save this. So in order to save this, I need to use what test.java, because class name is test, right? Let me run this. For the running, java c space test.java. Compilation is successful because it is just blinking in the new line. It means the compilation is successful. So java space test. It was amazing. So we are able to see the only print call. But the control flow, if you look at the control flow, so many things are out. So in this example, what I am trying to do is, I am taking a statement. I am writing a println statement that is going to throw an error. The statement that gives me the trouble, that gives this application a trouble. I'm trying to use 10 divided by 0. See, these things are not wired in the Java programming language. If the main thread finds this instruction, it cannot execute this instruction, right? So see, it has to go through the compilation. I have just saved this. Let me run here. Java c space test.java. So compilation, it is successful. It is not giving me any errors in the compilation. But when I run this code, see, this is an error. What is the exception? So this has happened in the exception. See what it says. Let me copy this and paste it. Before that, let us understand this program, this particular program in the stack frame, so that there will be better understanding. So I need your concentration here. Let me take the new notepad. Right. So over here, I am trying to copy paste the same code. So now this is the code. Very simple Java code. So here no changes. If you see there are no changes, I have added the additional line, which is a troublesome line. It is going to give me the trouble. The line is 10 by 0. It is going to throw an exception, right? So again, we already seen that a stack frame will be created, and each and every method will be stored in the stack according to the thread flow, according to the main thread flow. Right? Let me write that quickly. This is the main thread. The main thread will get access to the main method. Right? This is the main method. Right? From here, the control will go to the first instruction. So this is the first instruction. Right? So since the control started from the main method, this main method will be sent into the stack frame. Right? And again, from here, the control goes to eat biryani. If the eat biryani will be in the stack frame. Right? From here, again it is saying that we are calling another method, which is eat more biryani. Eat more biryani. Right? the eat more biryani, it will be executing the first instruction because it is not a trouble instruction, it is a normal instruction. So the output is going to be what? It was amazing. No doubts about it. So here it is encountering an exception, because in Java you cannot divide any number. You can't divide 0 with any other number. They will throw us the arithmetic exception. Right? So what happens as soon as the main thread encounters this instruction, what it will do? It will check if eat more biryani method has any capability, has any has it tried any handling code to handle this exception. In other words, it will check if eat more methods has any instructions that is going to handle this exception. No, there are no instructions to handle this exception. Right? What it does, the main thread will terminate this. Right? So again, after terminating this from the stack, again it is going to check with the caller method. What is the caller method here? Eat biryani was called inside the eat biryani method. So this is the caller method. It will check with the caller method if it has any instructions to handle this exception. So it has also, there are no instructions given here to handle this exception. So this will also be terminated. Again, it will check with the caller method. So here the main method is a caller method, right? Eat biryani was called by main method. It will check with the main method if it has any instructions to handle this exception. No, main method also now does not have any exception. Then again it will check with, to whom it will check? It will check with JVM this time. It will check if there is any handling capability with the JVM. This is the JVM. Right? Even JVM will not, because it's our responsibility to make sure that this exception is handled, but we did not handle this exception, isn't it? It is going to keep checking each and every caller method. At last, it will end up in checking with the JVM. What JVM will do here? JVM will create an exception object. It's very important. JVM will create an object. You already know that the object will be created what? With the help of new keyword, right? So this time JVM is going to create an object. So we can call this as what? We can call this as exception object. Right? So this exception object is going to have some instructions. So what kind of instructions it is going to have? It is going to have what kind of exception it is throwing. Right? It is going to have the name of the exception. Name of the exception is what? Arithmetic exception. Don't worry about this. We will see all this in detail in the future classes. But this is just just to understand what is the mechanism of handling this stack mechanism. We're just learning about the stack mechanism. Okay. So it is going to have description. It's going to generate the description. It is going to generate, if you see here, this exception object is going to generate all these things. All these things that you see here. The exception object is going to generate all these things that you see here. So this is what it is going to generate. It will generate all these things. It will generate all these things, right? And it will display this in the output. Before displaying this, that's why in the display we have got all this. The reason we have got all this is because internally JVM is creating an exception object, and it is storing all the generated all the remaining information. What kind of exception is this? Exception is arithmetic exception by 0. Now, what is the caller method? First, it occurred in eat biryani method, line number 17, right? Eat biryani method did not handle this exception, so it was checking with eat biryani method. I mean, eat more biryani method, there was no exception line to handle this, and it was checking with eat biryani method. Then it was checking with main method. Then all the three checkings got failed, right? Then at last it was checking with JVM. Since JVM cannot deal with this, JVM can do one thing. What is that thing? It can generate an exception object, and this exception object will save, will create all this in all this. All this information and it will be displayed to the end user, right? So this is getting displayed because these details are getting generated inside the JVM, which is collecting the exception information. Simply it won't be displayed because internally exception object is created, right? This is the simple mechanism for what. If anyone is asking you what is the what is a stack mechanism, it is called as runtime stack mechanism in Java, right? And we have studied till now it is a runtime stack mechanism, but we can also call this as since the exception is handled by JVM itself, it is called as default exceptional handling. What do you mean by that? Default, this is also called as default exceptional handling. Is for that. That's all for that. This is all about what? Runtime stack mechanism, right? So this is always stack because whenever the methods are getting executed one after the another, all the method information will be stored inside the stack as it is going to use LIFO principle. We have seen this in collections. Last in first up. We have seen all this in collections. So this is the memory area, right?